Everyone, this question is about complex numbers. On an Argand diagram, shade the region satisfying the argument of something is between this angle and that angle. This is a half line. So to find the starting point, we have to make it in the form z minus z1. So we turn this into minus something. So notice that if you expand, you're gonna go back to the original minus 1 minus 2i. So now we know the starting point, which is 1 2, that's the coordinates, and for the angle we start from negative 1/3 pi. So negative means in clockwise direction, so this is from negative 1/3 pi, and this is positive 1/3 pi. So the graph should look like this. We have the starting point at 1 2 and the angle from minus 1/3 pi to positive 1/3 pi. This is the part we shaped. Now for the real part smaller than or equal to 3. So the real axis is this axis. So real part is like the x in the Cartesian coordinates. So this means the x is smaller than or equal to 3. So just like x equals 3, we have a vertical line x equals 3, but smaller than, so we shape the left side. So if we combine both, we're gonna get this kind of combined Argand diagram. So we shape the combination or the intersection. So for this x-intercept here, so pi over 3 is 60 degrees. Okay, so pi over 3 is 60 degrees, and we know that this length is 2, and if you want to find this length or this length here, that's going to be using tangent. So tangent 60 degrees is 2 over this question mark, so the question mark is 2 over tangent 60 degrees, which is, if you use a calculator, around 1.15, which means this distance from this point to this x-intercept is more than 1. So that's why it's gotta be 2 point something, it's gotta be to the right of 2. Okay, so if you draw this line kind of like this, you will lose a mark because it's not the right x-intercept. Okay, so it's important to make sure that this line is intersecting the x-axis or the real axis around here. Now calculate the least value of arc z, so the argument of z for points in the region. So the z is a line from the origin, so from origin is the origin to any point in this shaded region here. So it could be to any point in the shaded region. Okay, but since we are looking for the least value, we are looking for the point such that we get the smallest angle or the most negative angle. So this is the z we are looking for, because when it's touching this shaded region at this point here, we have the smallest or the most negative angle. Okay, so we are looking for this theta, it's going to be negative something. So to find the theta, we can analyze, we can start with this kind of triangle here. Okay, so if we look at this triangle, we know that this distance from 60 degrees. So this distance from here to here, it is supposed to be 2, because the starting point is 1 2, and this is x equals 3, so this distance must be 2. That's why this is 2. Okay, and pi over 3 is actually 60 degrees, so if we use degrees, pi over 3 radians means 60 degrees, so this angle is 60 degrees. So now we can find this length using tangent. So tangent 60 degrees is the opposite, which is question mark, divided by adjacent, which is 2. So the question mark is 2 tangent 60 degrees, which is, in your calculator you get 2 root 3. So this distance is 2 root 3. So this distance from this point here, from y equals 2 to this point here, must be 2 root 3. Okay, now if you want to find this distance, of course it's from the origin to, this is the x equals 3, so this length is 3, and this distance is of course 2, so that's why this is 2, which means if you want to find this distance, there will be 2 root 3 minus 2. That's why we get 2 root 3 minus 2. Okay, so if you look at this triangle here, we have the angle, we call it theta, we have this distance is 3, this is 2 root 3 minus 2. We can use tangent equals opposite, which is 2 root 3 minus 2, over adjacent, which is 3, and using inverse tangent we can find the angle in radians. So that is theta, but remember it's actually negative because the direction is in clockwise direction, so it's minus something, so it's minus theta. All right, I'll see you again next time.